Okay, welcome back, guys. So I guess everything's set up here. So where did we leave yesterday? So let's just give you a recap. So yesterday we were trying to add the new driver, a new disk drive into our Kemu, and then try to get the registers and interrupt values for it from the DTD. But yesterday we were only able to manage to read the register. We were not able to read the interrupts for some reason because the interrupts value seemed to be 0, and that is what we were debugging in the end. So in general, overall, this is to allow us to use an external drive and also write the block drivers for it. So these are the use cases that we have. So to even start writing those stuff, we need the actual driver to be present, and for that we need the registers and the interrupt. So this is what we have been doing. So let's just continue. So this is what we wrote yesterday. It's a disk get drive info. We just get the yesterday we also managed to add the what is that, page table entries for the DTV range, because Kemu puts that in under Xerox 40,000 something. So we just had to add some extra table entries. So this is our virtual base and it's 8540 and it is mapped to 4000. So we could just use this directly, and this will be called from kmain. So MMU is already enabled. So I could have done it in the start, but I won't have UART to do the debugging, and without UART it's just so fucking hard. So I believe it's just better to just just call it from the kmain, so we'd at least be able to debug it a little bit faster instead of just manually going through GDB. And what did we do yesterday? Most probably we just we try to add the new condition like inside the token begin. So we are just passing the DTD, and it's just structured. So we are passing the tokens, and one of the token is token begin, and within that we are looking for VAR is like a virtual memory mapped IO. That's the word we are looking for. So if we have that, we are inside which IO, and so we can get into token proc. If that's like within the token, within the initial node, and there we are trying to check if the value is reg, because we want to read the register, and this part works just fine. We were able to read the register, and I have added it to the output. We are giving it a input, so we can input array, so we can populate it with the outputs. And then we do have another prop that we can read, which is the interrupt, which is gonna give us the interrupt number. But in our case, it's just does not like to work. I don't know why. Well, we're still debugging it. Let's see how we can do it today. So here, yesterday we were just trying to see what's the total length that we want to read for this particular interrupt, and it turns out we just need to read 12 bytes, and initially I was reading 16 bytes, which is read B32, which is 32 bits. But that would imply we are reading past it, and we also increment that value. That was just fucking with us. So leaving that, I was able to like I was able to figure out that we don't have to do that incrementing part for this, and that was fine. But still, when I read the 12 bytes, I added an extra helper that is just going to read 12 bytes, and it does not seem to work. And where's the one? Not this. Yeah, here. So this is where we almost got the name of it. And actually we didn't get the name, we just printed everything and we just figured out what we wanted to. It's like this, we bash build it, and if we run it, what? We fucked up big time. What the fuck? It's 3 camo. Oh, is my fucking command is stuck? Is my recording still going on? Okay, recording still there. Am I sure that recording is going on? Looks like it's not. Wait a minute, let me try it once more. Let me just remove this and add it. It's screen capture. Okay. Hopefully you guys can see it now. Well, at least I managed to find it now and not after the. Let's bring forward others. Move up. Okay. Okay. I guess now you guys can see it. Okay, so far it was not working. Okay. That's bad. Well, so what I was saying is that currently we managed to write a helper to read that 12 bytes, but still it does not seem to be working because our initial helper was reading 32 bits, which is 16 bytes. But here we only want to read 12 bytes. But my question is, even if we read 16 bytes, unless we increment the value, it should not matter. But turns out it is not working that way. So I'll just let me just redo this. Let me just call read 30p32, and we are not incrementing it. So if we read it, what happens? Let's see if we read, what do we get? UART interrupt number. Let's put D here and put num1. Let's try now. Okay, we already have an issue here. I forgot that. Yeah, we just tried to run it and we ran into a fucking. Okay, now it works. I don't know how it works, but it works now. But as you can see, We have five outputs. There is the results, and the first results, and we have the results for the total size, and we have the three results, which we only populated this, which would be the interrupt number, but interrupt number is 0 in our case. I have no fucking clue. Hopefully at least this recording is working. So what do we do now? We have the number. We checked if we are not incrementing over that value, so next input is able to work fine. Now all we have to do is figure out why this interrupt does not have any value in it. Also, is it possible to have 0 as interrupt number? For which IO mapped registers in DTBs, interrupt number is possible to have interrupt number as 0. Okay, interrupt number is not valid. So it's definitely not 0. So we definitely have some issue. So this is how my print message looks like. Hopefully it's still recording. Okay. So we are just printing every token. See, we have the token, and we have current strings. Okay. I think I can just put it here and expand it. We have to expand it, and let's just see. Okay, my hotkey is not working. Let's build it, run it, and this is the mapping, and we have an empty name, and that has some values, and then PCSI, and we have some stuff, and we have memory at 40,000 that has a reg and device type, and we have a platform bus, and it has certain things, and we have something, and then finally we have the actual which MIMO at a something, and it's DMA coherent, and it has the interrupts, and when we get into the interrupts, it says we can read 12 bytes from it, but when we try to read it, we just see zeros, right? If we are inside Virch.io, we would do that. So probably we never entered into other tokens. We've only entered into this particular token, and inside that we have the interrupts. So that part should be fine. Now we have which I interrupt, and we have the read which I just added, and let's just get into it. Okay, what if we simply read next? Wait a minute, wait. Let's think. So this is the token, and if it's the token we get inside it, and if it's the prop we read the length and we read the string and we move past it, and then we are just taking the value directly, and we are also taking the string from the string offset. Oh, maybe it is possible. Even here we are not supposed to get past it, right? But this happens after that, because first we get into interrupts. 1 2 3 4 1 2 3 4. And it's 16. Let's just put p minus 16. And 8 and 12. Let's just see what happens now. And would we keep going? Okay, so now we were able to read more values, because as I said, here we were simply incrementing it, and then even this length value again will be incremented here. So yeah, so if we decrement it again here, it should be fine. Let's see if we have anything else after that. We do have a lot of stuff. We have two MIMO, and both of them seem to have, actually we have lots of MIMOs, and everyone has interrupt number as 0. That does not make sense. So most probably I am reading the register value in a wrong way. Yep. Looks like that. Also, how do I know which one of this which IO is the one that is actually pointing to my drive? That's not the question. Okay, let's first we have interrupt. We check if a length is less than. Then we check. We just print it, and for every interrupt we have 12 bytes. And then we have the reads, and when we try to read from that we don't see anything. At least we should see some random value in case, because we are reading 32 bits out of it when there's only 12 bytes. Still, at least if there is something, we should see some random value there, which we do not see. So most probably we are doing something wrong. But I have no idea what the fuck would that be. Let's just try one more thing, which is to change this. Right way to add a drive to Chemo Arch 64. I'm using Arch 64, right? Yes. Don't fucking care. Using device and which IO with is more explicit and recommended. Why is that? Okay, well, let's try it then. If it hallucinates some random shit, we can fuck it up. What does it do? We have added the driver to just none. We have given an ID for it, and we have actually set that it's a virtual BLK device with this. Let's try then. Still don't have any interrupt number. Interrupt numbers are still, but do we see anything different, like in which MIMO? Do we see anything different? Not at all. It's still the same. Or if we remove everything, will we see any Virchayo? Let's see. Looks like we still see a lot of Virchayos. Maybe that's the issue. Maybe the particular fucking thing is not even added. Because even without anything, okay. Yeah, without anything here, because I just commented out the whole fucking thing, we still see those same witch memos. So maybe that was not added. Okay, now it's time to fucking read docs. Add drive to Kernel. Okay, Arch. Maybe I'm thinking about it in the wrong way. How to add and try next for trying to camel. Okay, I have to. Maybe I could just use camo image to create one. What is that? We did everything exactly like this. Maybe this is not how it should be. How to launch a camera image. Yeah, this is what I want. I want a file system image, and I have my own kernel image which is added here. And it's a device. Maybe that's the issue. Maybe I should put my kernel inside that driver. I have no fucking clue. Let's see. For First of all, is it possible to have two devices? It should be, because we can just have one drive that has operating system and another the drive that is for files, and it's just normal. So I don't think that should be a big issue. And it is there. What if I do the same thing with X4 image? But in this case, why I have given this address is because Camus should start the actual execution, the initial jump into this. That's why this is here. And at this location, this kernel ELF is mounted. Okay. Time to ask some help. The instant. Okay. I have my kernel running as ELF mounted, mapped into 0x8, and Camus starts from there. It all works fine. Now I want to add file systems port for my kernel. Custom kernel for my kernel. So I need to add include drive to it and read the registers to access that drive from DTV. But how explain how will this design work for Camus and my kernel? Is it okay to pass? Is it okay to have a drive that has the ELF plus my external drive? Let's see. My ELF is directly routed into RAM. It's okay. From that, mon file system support must expose a device. Okay, kernel must implement driver. Okay, that is, I guess, at least I believe that is what my block driver is gonna do. And we also need the higher level X driver. Leave that part. Okay. Devices are not legacy PCI unless you add them. This is the fucking thing, I don't see it. Okay. Maybe I should get into this compatible and read what's inside it. Okay, let's try that. But still, we read the interrupt values for every which IO, so that shouldn't matter either. Well, still, just to be sure, let's try one more thing. That is to read. Oh, fuck me. What the fuck did I do? I just don't see. Open GTD. Let's just fucking write it. So if we are inside which IO and string of 0 equal to, what is it, compatible, COM, same, and string 1 equal to O, and string of 2 equal to, what is it, yum. If this is the case, I'll be inside it and I can actually read. Let me just check the length first of all. You are printf inside compatible. I don't know, I just spelled it wrong. Whatever. No, I'm printing length, so it's just T. I just print length, and yeah, I think it should be good. Let's run it. And if we are inside compatible, even there it says it's 12 bytes. That does not make any sense. Maybe these values are inside the, okay, compatible, it's wait, for register we are reading it directly here, but compatible it is a string, so we'll have to read it like this. We'll have to read the string offset. We'll read the string offset, and but it says length is 12, then how can I read this? Okay, whatever. Let's try this and see how it goes. Let's put p minus plus equal to 4, and let's print string, and it should be yes, and it should be string. Let's see. Well, we are doing something wrong, that for sure, but let's see. Okay, now we have error because we tried to read some unknown value and it just fucked us. we come into this, we read the initial token, we increment it, and then we get into the name. If we are inside with IO, we keep doing the same fucking thing. And then we read the length, we increment it, we read the string offset, and we incremented it. Maybe that's the issue. You're not supposed to. After token will have the length. Token prop will have the length, right? We have the length and the name representing it. Both fields are integers. Gives the offset of the string, so it's fine. Okay, so first we read the length and we move past 4 bytes, and then we read the offset and we move past 4 bytes, and then finally we do something like this. Why do we have to move past that length of the property value in bytes? Properties value in bytes. I think we're not supposed to move past that, because this length will just give the length of this string offsets, and these two are static length, that is +4. We just get past it by 4. We don't do anything. If we get past both of them by 4, we should not have to do this. But in case it is 3, because it's not padded correctly, then we move past it. And here let's just add p plus equal to 4. P is the pointer inside the upper structure, which is the metadata. Maybe we might have to increment the string, but it already gives the string offset, so we don't have to increment that either. So I think maybe this time we should get something different. Let's see. Okay, we fucked up even bigger. So this time we just enter into parent and we fucking stopped. Why? Let me just see. We come here and we say it's an endless loop, so we get into it, we read the first token, which would be some starting, and we increment it, and then we get into the token, and if we check if the token is token begin, we take the name from that. Wait, if we read the token and we, as soon as if we increment it, then how can we actually read it properly here? Oh fucking hell. This is just fucking stupid code. Okay, let me just try one thing. P is pointing to data structs, not data strings. So inside this, we should only okay, so node can okay, so this is correct because initially we just check if it's a node beginning, so we can move past it. Now we can start to read the bytes, which is a null terminated string. Then as long as it's not null, we keep incrementing. At some point it will be equal to null. Then we increment it once, and then we double check if the value is padded with 4 bytes. This is perfect. So I think the token begin implementation is fine. Now we have the token prop. Inside token prop, we have a structure that can have a static length, which is 232 bits. There's length and name offset. So we get the length, we increment it. We get the string, we increment it. What is value here? Wait, we have the length and we have the name offset. Okay, after this struct, the property's value is given as byte string of length L, length len. Okay, then I think it's fine. After we read the length, we move past it. After we read the name of string offset, we move past it. And value is starting from there. So we read we read certain bytes of it, and then we have to increment it by length, and we should have wait. What the fuck is string offset? Why the fuck am I reading a string offset here? Value will be here. It won't be a string offset. But how do I know if this will be a string or a offset within the string struct? There's no such fucking thing here. Structure is composed of sequence of pieces, each begin with a token, 32-bit integer value. Some tokens are followed by extra data, the format of which is written by the token value. All tokens shall be aligned 32-bit boundary, which may require extra padding. There's 5 different things. If it's a node, it marks the beginning and it shall be followed by unit name of extra data. So the actual data is here. It's not within the string. Name is stored as null and shall unit address. If any node name is followed by no extra data, it is followed immediately by the next token. Node prop token marks the beginning of representation of one property in device drive. It shall be followed by extra data describing property of the property. It shall be followed by extra data describing the property. Length of the property's value in bytes. Okay, so the actual value is within this for sure. So as soon as I get into prop, I read the length, I read the string offset, and I can use that string offset to check what is that current value is, current type is, and then I have to read the value directly from P. So I have to read the value directly from P, which in our case would be a character star. So we don't need a string here. So let's just add value, and then I can move past length. That's it. I move past length. It should be the next token, and then we can have padding if needed. Okay, let's see. Still not working. It will after current string is parent. If it's not, we just move here and we move past it and we break. And then what happens? And we read the next token. If the next token is not within, okay, maybe I have to not break here. If it's not, I have to increment P plus equal to 4. And end I can just return. If it's end nodes, what is token end node and token end? I don't know. But for all the tokens, we do have to increment it by 4. Because every token is of 32 bits. It's a 32-bit value. If it's a default token, we return directly. So that is fine. Put break here. It has to be one of the token. If not, we keep trying until we reach the token end. Okay, until we reach token end. Okay, now let's see. Okay, where the fuck did we return? Why did we reach token end? Or why did we reach this? We were inside string as parent. We were here. We incremented. We inside token. And then we checked the name and we were able to get a full name. So we move past it and we add this and we break. So now we read the next token and we increment it. And now if we switch, okay, let's just print what is the token, current token. Token. Now let's see. Okay, we start off with that and we start off as token 1 and name is nothing, and then we get token 3 and then we have interrupt parent and we have random token. So okay, let's see if this is what fucking us. And then we get token 0. Okay, so we definitely need this. But first of all, how the fuck did we have an issue here? Wait. Okay, let's just enable this. And I get a wrong token there. Something is wrong. We get this, we get that. We start at data struct and we get the first token and it is token begin. Token begin name, and we have the name there, which seems to be null. So we move past that null. We have to check if p is equal to p equal to, and then we do some padding and we break. Current token is 0. There's no such thing as 0 token for me. We have nop, we have end, we have end nodes, we have begin, we have end, we have prop, we have nop, and we have end. That is how it should have. Okay. Okay, fuck. Oh shit. We have edge base. I'm moving past 4 and I have the token. I check the value. If it's 0, I just move past it. Oh, it's not. Fuck this. It's this. And current token is 3. And current string is, and we get a current token as 3, which is prop. And we read 4 bytes, and we read 4 bytes. And we are inside as current string. Okay, we didn't go inside it, we went here, the current string. So current string is reg. Then we would have went inside this. And current is intra, we would have went inside this. And if there is nothing, okay, if there's nothing, we have to do something. If there's nothing, then we have to move past it by showing that it is length. So let's do it inside like this and remove these. Here I'm already decrementing it. I don't have to do this because it's done in the end. Okay, now let's see. Okay, so we have moved past a little amount and then we fucked up somewhere in compatible because that's the new code that we added. And that is compatible. Fuck me. That's compatible. Okay, it's here. And here compatible, even for compatible, it is supposed to have the string. Okay, we are not supposed to read string offset. We check if the string offset is compatible. If it is, we print the length and then we take the value and we print the value. And we print the value and yes, that should be it. We got the thing and we got the value. And for this case it should be jar pointer and we can print it. It looks like it's not. Did we go inside compatible? No, we didn't go inside it. So somewhere we are missing increments. Where would that be? Mm-mm. Mm. We don't put any incrementing inside this. Okay, we don't. We only put it outside it, so that should be fine. And then we have token end nodes and token knob and again token nodes. Okay, let's see. We reached token end. No, we did not reach token end. Last thing we did was inside token 2. What is token 2? We were inside the token end nodes. And next time we read token. Oh, okay. Maybe it's possible that we might have to add this in this and this and this. Nope. We are doing worse than yesterday today. Okay. It's been an on off 15 minutes, so we still have time. We still have time to try and fix it. We have the virtual DDB base, and we have the destruct, we have the token. I mean, we could just check it in GDB and see what was that there. But there's lots of print messages, so it will be okay. Move past it. Take the name. Check if it is not equal. If it is equal to 0, we set inside 0. Only if it is virtual we set this. And then we read token prop. There is the length. And then we have the name offset. Name offset would give the string offset. and we increment it by 4. Which may be 0. And we get the p-value, and we have the current string. Check if it's a register and do some random stuff. And we finally have the interrupts. Only thing we are reaching currently is probably this value. We read a token and increment it, so that is also fine. And we read the length and increment it, and we read the offset. Now we just say we are actually inside this. We should have proper padding. Let's just brute force it. Every time we reach 4, we just increment 4 and we break. So at some point we should be able to get past it. See, we just brute force that fucking thing. But this is not good way, but at least it works. See, sometimes we reach some random values and we are just keep on incrementing it until we get past it. That's not good. This happens every time we reach compatible. Every time we reach that, we are not able to get past it. Fuck it, so it must be this fucking thing. Every time we reach the current string as compatible, COMP Next time the current token is ends. And for end nodes, we are incrementing it by 4 and then maybe we are fucking it up. Because for end node, it's just the token, it does not have any value. So we have already incremented the token for 4. I think it's the same for NOP too. And it's the same for in token too. It's the same for NOP. So we just fucked it up by adding this +4s. Okay, now we managed to get past everything without having to go through that extra 4 steps. And we do have Virch IO MIMO. Wow. And there's lots of Virch MIMO. Fuck me. And out of which one is my actual MIMO? That's just sad. Well, at least our parsing is back to initial state where the interrupt number is 0. Now we have to think about the interrupt number. Okay, where is it? If it is interrupt, we get the string which is interrupt, and we also know the length which is L, and we are not supposed to, well, at least we simply read it as 32 bits from there. It shall be followed by the extra data, so it should have the extra data after once we have the initial token. We read the two things, which is the length and offset. And inside interrupts, we don't see anything. We know the length that is working, and it's 12. Well, let's just print PF0 every time. And it's 0. That number is always 0. Fuck me. Okay, we did use that. So only thing left for us to fucking do is that. One, 5, 6, 7, 8. Interrupt value will be found after the token, right? It says it has 12 bytes in length, but value seems to be 0. Okay. In that case, let me try this way. Let me read the 4th byte. That's my fucking DTD. Let me read the 3rd byte. Still the interrupt number is the same. Okay, wait. Let's just try this then. And I will 0 while less than 12 plus high. Let's see what's inside it. Percentage D, find this. So it's I comma PFI. Okay, let's see. So it does have it. It's just I was fucking reading it in the wrong way. And 16 is the first driver, and the interrupt number is 16. So it works. It fucking works. Oh my fucking god! It all has to do with my fucking. I knew it. I was just reading it in a wrong way. That's why it didn't work, because I added this helper, but I was thinking, because previously I was shifting bits to change the Indianness. Here I try to do the same thing. I guess I assumed something wrong, and it cost me 2 fucking days. Fuck. Mm. 32-bit. I have that fucking thing. What? Oh, I was fucking only reading 3 bytes. What are we doing here? We have the p-value, and it's going to read 32 bits from it and add 0 to it. Okay. So here what I'm doing is that I know that the upper wait, 0 is the first byte, and I'm moving that to 24th, and I'm moving the second byte to 16th, and the third one to 8th, and the 0th one to 4, 0 to 4th one to the 0th. This is what I thought I did, because now if I do the same thing here, it is correct. It's just that I only try to read the first bytes, and for those things there is only 4 bytes to read. In my case, I have 12 bytes to read. Yes. Wait. 4 bytes into bits. Yeah. So, because I was only reading 4 bytes, I fucking assumed that. I guess I fucking assumed something wrong, because in my case, this is correct in a way. It's just that I was reading the only the upper bits, and then there's like 2 other 4-bit blocks which I did not even read, and the upper blocks are 0. That's why I was always getting 0. The upper blocks are 0, and I have 2 more blocks because it's 12 bytes, and I was only reading the 4 bytes, and I was fucking assuming something. Ah, shit. So this is correct. So we don't need this. Moving the bytes order. 4 bytes are read here, and okay, that's the fucking issue. Oh, it's so fucking stupid. No, I guess I did correct, because I did try to read it three times, because this was just for testing. This was just testing for testing purposes. I wanted to check if the value was there, and I wanted to only read the num. Okay, fuck me. And maybe I should have just kept the entire thing and tried it. Maybe it would have worked. Because here I did try to read the rest of the things, but for my test cases, I just uncommented it. Fuck. I think I can just use read 32, and this will be the type, and type will be, wait, what's the order I have to use? Type is 0, and num is 4. And edge is was adding it like this, but still that was correct. It's just that I should have kept the entire thing, so I would have gotten the answer. I kept reading the first value, and the first value was always 0, and I fucked up. Okay, not bad. It only took me 2 hours to figure it out. So it's not bad at all. Let's just set those values and run it and see what happens. And it works. And currently we have the final value. We can break as soon as we find the first value. Here there can be multiple memos. We are returning after we found the first one. Okay, let's see. And we have it. Okay, wait. We can't simply return, but as soon as we can just say we can have a flag. We can return here. As soon as we read the first register. After reading first reg, we return. Because first we read the interrupt and then we read the register. So we can return after we read the register. So now we have the register value, we have the size, and we have the interrupt number, and we also have what is the type of that value. Oh, fuck me. It took me just 2 hours to fucking figure it out, and it was entirely my fucking fault. I knew it still. Maybe I should have tried to read it properly. Because I have it here. I knew that it was 12 bytes, so I need to read 3 times. But I was keep fixating on why num being 0, but actually first value was type and it is always 0, and num is the second value. Maybe I should have at least tried to keep that as the value. Okay. And everything else works just normal way. Okay, at least now we have the drive info. Now we can just use this interrupt to register a case, and then what do we do? We have to dynamically pass a value to our handler, because we are getting the interrupt number dynamically, so we'll have to probably somehow add it here in a dynamic way, or we could just simply add 16 here. Okay. Default case, maybe I can check if the number is within some memory location where I can put the actual interrupt number, something like that. Okay, whatever, at least we tried to parse it and we were able to parse the MIMO and we got the register and the interrupt number. Okay, that was so fucking annoying. Okay. Okay. Thank you guys. We'll see you next week. Then next week I'll try to finish at least the block driver. So now that we have the register and the interrupt number, we should be able to work on that without any issues. At least maybe not much issues. Let's see.